Example 1. Graph the function and identify key points on one full period. Part A, y is equal to 2 times the cosine of x. Okay, let's see. The amplitude for this problem is the absolute value of 2, which is going to be 2, and the period is going to be 2 pi. All right, let's make our chart. We'll choose our angle x, and then we are going to take the cosine of that angle, and then we are going to multiply 2 times the cosine. All right, the zeros on the cosine curve happen at pi over 2 and 3 pi over 2. And then the maximums occur at 0 and 2 pi, and the minimum occurs at pi. So these are our 5 key points right here. This is a max. This is a max. This is a min. This is a 0. And this is 0. And this is true for the parent function, y is equal to the cosine of x. So these are the 5 points we want to get because there are key points and we can get a good idea of what one period is going to look like. Okay, from our unit circle, the cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine at 3 pi over 2 is 0. And the cosine at 2 pi is 1. And then in this column, 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. 2 times 0 is 0. And then 2 times 1 is 1. So the ordered pairs I'm going to graph on the next page are 0 and 2, pi over 2 and 0, pi and -2, 3 pi over 2 and 0, and then 2 pi and 2. All right, let's go to the graph paper and draw this picture. Okay, let's see, we got 1 pi over 12, 2 pi over 12, that means this is going to end up being pi over 6, that's right here. 3 pi over 12, that reduces to pi over 4. 4 pi over 12, that reduces to pi over 3. 5 pi over 12, not on the unit circle. 6 pi over 12, that reduces to pi over 2. 7 pi over 12, not on the unit circle. 8 pi over 12, that reduces to 2 pi over 3. 9 pi over 12, that reduces to 3 pi over 4. 10 pi over 12, that reduces to 5 pi over 6. 11 pi over 12, not on the unit circle. 12 pi over 12, that reduces to pi. 13 pi over 12, not on the unit circle. 14 pi over 12, that reduces to 7 pi over 6. 15 pi over 12, that reduces to 5 pi over 4. 16 pi over 12 reduces to 4 pi over 3. 17 pi over 12, not on the unit circle. 18 pi over 12, that reduces to 3 pi over 2. 19 pi over 12, not on the unit circle, but 20 pi over 12, that reduces to 5 pi over 3. 21 pi over 12, that reduces to 7 pi over 4. And 22 pi over 12 reduces to 11 pi over 6. 23 pi over 12 not on the unit circle, but 24 pi over 12 reduces to 2 pi. Okay, so here are all the angles on the unit circle. And we're going to draw our graph based on this. Okay, and let's let 3 blocks represent 1. This will be positive 2. And this is going to be a negative 1. And this is going to be a negative 2. Okay, so now we can just sketch our graph in there. All right, our points were 0 and 2. That's going to be up here. And pi over 2 and 0. That's going to be right here. And pi and negative 2. That's going to be down here. And 3 pi over 2 and 0. That's going to be right here. And then 2 pi and positive 2, which is going to put us right up here at this point. All right, and all that's left to do is to sketch the graph in there and just make a nice, pretty curve. Make sure you get all the key points in here. And there we go. This is 2 times the cosine of x. Part B is asking us to graph negative 1/3 times the sine of x. Okay, I'm going to change colors here so we'll be able to tell the difference between the two graphs. I think I'll just leave this red. Okay, and I'm going to make another chart. So again, I'm going to choose my angle, and then I'm going to take the sine of that angle, and then I'm going to multiply it by negative 1/3. And the sine has the same key points that the cosine has, in that its maximum, minimum, and zeros occur at these angles: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we know this from the unit circle. So I'm going to choose the same angles. All right, and using the unit circle, now I'm going to take the sine. The sine at 0 is 0. The sine at pi over 2 is positive 1. The sine at pi is 0. The sine at 3 pi over 2 is negative 1. And the sine at 2 pi is 0. In the next column, I'm just going to multiply the sine column by negative 1/3. Negative 1/3 times 0 is 0. Negative 1/3 times 1 is negative 1/3. Negative 1/3 times 0 is 0. Negative 1/3 times negative 1 is positive 1/3. And negative 1/3 times 0 is 0. So the ordered pairs I want to graph will be 0 and 0, pi over 2, and negative 1/3. These are the first column and the last column. Pi and 0, 3 pi over 2, and 1/3, and then 2 pi and 0. All right, and let's see. I would love to make this a little bit thicker. That's better. All right, let's go over to the graph paper, and we're going to draw this on the same graph as the cosine curve. First point I want to graph is 0, 0. That's going to be right here. The next point I'm going to graph is pi over 2 and negative 1/3. Pi over 2 and negative 1/3. Now, if this is negative 1, this line right here is going to be negative 1/3. So we're going to have a point right here. Then we're going to have pi and 0. That's going to be right here. Then we want 3 pi over 2 and positive 1/3. Here's 3 pi over 2, and positive 1/3 is going to be right here because remember positive 1 is up there. And then the last point we're going to graph 2 pi and 0. Which is going to be right here. Okay, so our second graph, we're just going to sketch this in here, is going to be pretty flat. If you think about it, it's really going to hug onto this x-axis here, like so. And really, it shouldn't have gone up above 1 in this section here. That's supposed to be the maximum point, but this is just a sketch of what our curve is going to look like. So the red one is y is equal to negative 1/3 times the sine of x. Example 2. Given y is equal to 2 times the sine of 4x, identify the amplitude and the period. All right, the amplitude is just going to be the absolute value of 2, which is 2, and the period, which is normally 2 pi, is now going to be 2 pi divided by 4, and that reduces to pi over 2. Part B, graph the function and identify the key points in one full period. Okay, I'm going to make my chart again. I'm going to pick my angle, and I'm going to multiply it by 4. Then I'm going to take the sine of whatever angle I get, and lastly, I'm going to double that. And all I'm doing is using the order of operations here to try and figure out how to do my chart. So I start here with x, then I multiply it by 4, then I take the sine, then I multiply everything by 2. So we're starting from the inside out. All right. Now I'm going to graph one full period. And remember, the period is pi over 2. Now normally it's 2 pi, so this one's going to be really short. So I'm still going to start at 0, but instead of going all the way to 2 pi, I'm going to stop at pi over 2. Now the key points are going to fall in between 0 and pi over 2. That means I have to have a 0, and I have to have a max, and I have to have a min. Now on the sine curve, there's a maximum at 0. And there's also a maximum back here at pi over 2, which means that the minimum should occur, I'm sorry, that's backwards. At 0, there's a 0 at 0, and there's a 0 at pi over 2. So the sine curve, there should be another 0 in there. And it should be exactly halfway in between 0 and pi over 2, because in the previous problem that we did, we had a 0 over here at 0, we had a 0 here at 2 pi, and then pi was our third 0, which was exactly halfway in between. So we're going to do that exact same thing. My job now is to figure out what number falls exactly halfway in between 0 and pi over 2. And the way I do that is I add 0 plus pi over 2, and then I divide that by 2. And that's actually going to give me pi over 4. Now this you can do in your calculator and figure out that it's pi over 4. I would do it without the pi's though. So I would just do it as 0 plus 1/2 and then divide it by 2, and it'll give you 1/4. And then just remember to put the pi on top of it. All right, let's go back to our picture. Here was a 0. Here was a 0. I had an important point in between right here. This was a minimum value, and it happened at pi over 2, which is exactly halfway in between 0 and pi. So what I'm going to do is, I know there's a key point somewhere in here between 0 and pi over 4, and that's the angle I'm going to choose. And the way I'm going to find it, once again, is I'm going to take 0, and I'm going to add it to pi over 4, and then I'm going to divide it by 2, and this is going to give me pi over 8. Now, don't worry, I know this angle is not on the unit circle. It's okay, because doing it in the chart this way we're going to wind up with angles on the unit circle that we can find the sine of. Okay, I got 4 of my 5 key points. The last one I'm looking for is right here. This was a maximum, and it occurred between the two zeros pi and 2 pi, and it was exactly halfway in between, 3 pi over 2. This is halfway, this pi over 2 distance there, there's a pi over 2 distance here. So now what we want to do is we want to find the angle that's exactly halfway in between pi over 4 and pi over 2. And the way we're going to do that is we're going to take pi over 4 and we're going to add it to pi over 2, and then we're going to divide that by 2. And in my handy dandy calculator, that's going to give me 3 pi over 8. Now, I'm going to know I've done this right if I can count these forward in increments of pi over 8. So we have 0 pi over 8, that reduces to 0. 1 pi over 8. 2 pi over 8, yeah, that does reduce to pi over 4. 3 pi over 8. And then 4 pi over 8, that also reduces to pi over 2. So these are going to be my key angles right here. Okay, in the next column, remember I'm supposed to take my angle and I'm going to multiply it by 4. So 0 times 4 is 0. 4 times pi over 8, that's going to give me 4 pi over 8, but that reduces to pi over 2. 4 times pi over 4, that's going to give me 4 pi over 4, but that reduces to pi. 4 times 3 pi over 8, that's going to give me 12 pi over 8, but that reduces to 3 pi over 2. And 4 times pi over 2, that's going to give me 4 pi over 2, but that reduces to 2 pi. And now you can see this column right here, y'all. These are the key points for the sine curve on the unit circle. So in my next column, now that I have my angle 4x, they're right here, I'm just going to take the sine. The sine at 0 is 0. The sine at pi over 2 is 1. The sine at pi is 0. The sine at 3 pi over 2 is -1. And the sine at 2 pi is 0. All right, in our last column right here, we've taken the sine of our angle. Now we just need to double everything. So I'm going to multiply 2 times this column right here. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. And 2 times 0 is 0. So the ordered pairs I'm going to graph on my graph paper will be 0, 0, pi over 8, and +2. Remember, first column, last column. Pi over 4 and 0. 3 pi over 8 and -2. And then pi over 2 and 0. All right, there are points we're going to graph. Let's go over to the graph paper. Okay, we're going to have to draw this out. Let's see, we could do 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, but that's going to be really, really skinny. So let's try and stretch this out just a little bit. We know that they're evenly spaced. So let's say we can make this be pi over 8, and this can be pi over 4, and this can be 3 pi over 8, and then this one can be pi over 2. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Okay. Our first point we wanted to graph was 0, 0. We'll put that one right here. Our second point, pi over 8 and +2. Oh, I forgot to do that, didn't I? Let's do that again. There's +1. There's +2. There's -1. and negative 2. Okay, so pi over 8, positive 2. All right, pi over 4 goes with 0. That's right here. 3 pi over 8 goes with negative 2. 3 pi over 8, negative 2. And our final point, pi over 2 goes with 0. That's right here. And now we just sketch it in. And this one's going to be tall and skinny. It's going to look kind of like that right there, except I didn't quite get to my minimum value there. So let's try it. There we go. Now keep in mind, the regular sine curve had a 0 at 0, and then at pi over 2, it was at positive 1. So the regular sine curve is just now reaching its maximum point, whereas the one that we just graphed, which was positive 2 times the sine of 4x, took our graph and condensed it this way, and it also stretched it this way. So it is taller, and the period's a lot shorter on it. Example 3. Given y is equal to the cosine of 3x minus pi over 2, part A, identify the amplitude and the period. And then B, graph the function and identify the key points on one full period. Okay, the amplitude. This is just going to be the absolute value of 1. That comes from right here, which is just going to give us 1. The period is going to be 2 pi, because that's the normal period for cosine, divided by 3. It came from right here, and that won't reduce. Okay, and that's part A, but before we can do part B, we can see, based on the parentheses right here, that there actually is a phase shift. Okay, so we need to know what that phase shift is, because before in our graphs we were able to start at 0 because there was no phase shift, no horizontal movement. But now we have some horizontal movement, and we know we're moving to the right. We just have to know to the right how much, and I'll give you a hint, it's not pi over 2. All right, the phase shift is going to be pi over 2 right here divided by 3. That came from right here. All right, let's remember how to divide fractions. We have pi over 2, which we are dividing by 3, which is the same thing as 3 over 1. So this becomes pi over 2 times 1/3. Remember, we invert and multiply. And then pi times 1 is pi, and 2 times 3 is 6. So our phase shift is going to be to the right, pi over 6. All right, let's come down here. Let's make our graph with our 5 key points on it. We will choose our angle right here. Then I'm going to multiply it by 3. Then with the order of operations, I'm going to do the parentheses. So that means I'm going to take my angle and then subtract pi over 2. And then finally, I want to take the cosine of that. Now, finding our key angles is going to be a little bit trickier here, but I'm going to use that little trick I had of adding the 2 angles together and then dividing by 2 to find the one that's in between. Okay, the first angle I'm going to choose is going to be pi over 6, because that's my phase shift. So that means something important happens here. It's either going to give me a maximum, a minimum, or it's going to give me a 0. And then the last angle I'm going to choose is going to be 1 period away from pi over 6. Well, to find that, I'm going to have to add pi over 6 to 2 pi over 3. All right, pi over 6 plus 2 pi over 3. Now, if we get common denominators, we're going to have pi over 6 plus 4 pi over 6, because 4 pi over 6 reduces to 2 pi over 3. And that's going to give me 5 pi over 6. Now, you can do this in your calculator, 1/6 plus 2/3, and it should give you 5/6. And just remember to put a pi on it. Okay, so I have 2 key points here. Now remember, exactly halfway in between here, something important is going to happen as well. It's either going to be a 0 or a maximum or not. And what I'm going to do to find this middle point right here is I'm going to add pi over 6 plus 5 pi over 6, and then I'm going to divide it by 2. Well, pi over 6 plus 5 pi over 6 is going to give me 6 pi over 6. But that reduces to pi. And then when I divide the 2 there, well, that's in reduced terms already. So my angle right here that's exactly halfway in between is pi over 2. There is an important angle right here that's exactly halfway in between pi over 6 and pi over 2. And I can figure that out by taking pi over 6 and adding it to pi over 2 and then dividing that by 2. If we get common denominators, we're going to have pi over 6 plus 3 pi over 6. This is over 2. Pi over 6 plus 3 pi over 6, that's going to give me 4 pi over 6. And then this is divided by 2. And then if I put that in my calculator, it's going to give me 4 pi over 12, but that reduces to pi over 3. My angle right here is going to be pi over 3. And finally, I'm going to have to figure out what this one is right here. And I'm going to do the same thing. I'm going to take pi over 2, and I'm going to add it to 5 pi over 6. And I'm going to divide that by 2. I'm going to put this into my calculator. And when I do, it's going to give me 2 pi over 3. Okay, so here are the angles that I'm going to be graphing. In the next column, I'm supposed to take each one of my angles and multiply it by 3. So let's see, 3 times pi over 6. That's going to give me 3 pi over 6, but that reduces to pi over 2. 3 times pi over 3, that's going to give me 3 pi over 3, but that reduces to pi. 3 times pi over 2, that's going to give me 3 pi over 2. 3 times 2 pi over 3, that's going to give me 6 pi over 3, but that reduces to 2 pi. And then 3 times 5 pi over 6, that's going to give me 15 pi over 6, but that's going to give me 5 pi over 2. Now these first 4 angles should look familiar because they're on the unit circle. This one is a coterminal angle to something that's on the unit circle as well. The next column here tells me I need to take my angle from this column right here, and now I'm going to subtract pi over 2. So pi over 2 minus pi over 2, that's 0. Pi minus pi over 2, that's going to give me pi over 2. 3 pi over 2 minus 1 pi over 2, that's 2 pi over 2. But that reduces to pi. 2 pi minus pi over 2, that's going to give me 3 pi over 2. And then 5 pi over 2 minus 1 pi over 2, that's 4 pi over 2. But that reduces to 2 pi. And now these should look very familiar to you because this column is the key angles for the cosine. And the next thing we're going to do is we're going to take the cosine. The cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine at 3 pi over 2 is 0. And the cosine at 2 pi is 1. And the points I'm going to graph will be pi over 6, positive 1, pi over 3, 0, pi over 2, negative 1, 2 pi over 3, 0, and 5 pi over 6, 1. All right, let's go over to the graph paper. Let's see, we can do pi over 6 here, and then we can do pi over 3 here, and then pi over 2 here, and then 2 pi over 3 here, and 5 pi over 6 right here. Now remember, these points are going to be exactly the same distance apart. We're doing this on purpose because we're finding the middles every time. And so I didn't have to use 2 boxes. I could have used any other increment. I could have put, pi over 6 back here if I wanted to, and then I could have had 4 boxes in between all of them. It would just stretch my graph out. It doesn't really matter. Okay, once again, I'm going to go up here to 1, and I'm going to go up here to 2, and I'm going to go down here to negative 1, and down here to negative 2. All right, let's see what we're graphing. Pi over 6, we want to be at positive 1. That'll be right here. At pi over 3, we want to be down at 0. It's going to be right here. And pi over 2, we want to be at negative 1. It's going to be down here. And then at 2 pi over 3, we want to be at 0. That's going to be right here. And at 5 pi over 6, we want to be at positive 1, which is going to be right here. So all that's left to do is sketch in the cosine curve, which is going to do something like this. And there it is. Now, how does this differ from the regular cosine curve? Let's see. At 0, the regular cosine goes up to positive 1. And then at pi over 2, the cosine is at 0. And then at pi, which would be about right here, it's going to go down to negative 1. And so the regular cosine curve with a 2 pi period and no phase shift is going to do something like this right here. So we don't even have a complete period. And so what happened was our graph stayed the same height because we found the amplitude to be 1, but it took my cosine curve and it changed the period. So we have more hills and valleys than we would in the 2 pi period. Example 4, given y is equal to 2 times the cosine of 3x minus pi plus 3, part A, identify the amplitude, period, phase shift, and vertical shift. And then B, graph the function and identify the key points on one full period. All right. The amplitude is going to be the absolute value of 2, which is 2. The period, normally for the cosine, the period is 2 pi, but now we're going to divide it by 3 right here. The phase shift is going to be pi, and we're moving to the right, divided by that 3. So we're doing this one divided by that one right there. And then the vertical shift is just this guy right here. And we're going to be moving the whole graph up 3. Okay. let's go get our key points on this graph, on the cosine graph. So we're going to pick our angle, then we're going to multiply it by 3. Then we're going to subtract pi, because that's in parentheses. Oops, that should be a pi, not a 4. Then we're going to take the cosine of it. Then I have to double it. And again, we're doing this by the order of operations here. And then the last thing I want to do is add that 3 to it. All right, so this is going to be a long one because it has a period change, a vertical shift, and a phase shift in it. All right. Now remember, my starting point is going to be my phase shift, which in this case is going to be pi over 3. And then 1 full period is 2 pi over 3. So 1 full period would be pi over 3 plus 2 pi over 3. That's going to give me 3 pi over 3, which reduces to pi. That means we're going to finish at pi. Okay. These are 2 of my key points. They're either maximums, minimums, or zeros. Now let's go get the one that's exactly halfway in between. That's going to be another key point. That means we're looking at pi over 3 plus pi, and we're going to divide that by 2. And in my handy dandy calculator, that's going to give me 2 pi over 3. So right here in the middle, 2 pi over 3. All right, there's 3 of my key points. Now remember, there's another one right here in between pi over 3 and 2 pi over 3. So let's see if we can figure out what that is. Pi over 3 plus 2 pi over 3. And we're going to divide that by 2. And this is going to give me pi over 2 in my handy dandy calculator, which is going to go right here. And finally, we want to get this 5th point, this 5th critical point or key point that's in between 2 pi over 3 and pi. We're going to take 2 pi over 3 and we're going to add it to pi. And then we're going to divide that by 2. And that's going to give me 5 pi over 6, which is going to go right here. All right, next column. All these angles I've chosen, these are where my key points are located. I need to multiply them all by 3. 3 times pi over 3 is 3 pi over 3, but that reduces to pi. 3 times pi over 2, that's going to give us 3 pi over 2. 3 times 2 pi over 3, that's going to give me 6 pi over 3, but that reduces to 2 pi. 3 times 5 pi over 6, that's going to give me 15 pi over 6, but that reduces to 5 pi over 2. 3 times pi is going to give me 3 pi. Okay, so some of these I recognize as being on the unit circle. That's good. Next thing I want to do is I want to take this column and I'm going to subtract pi. This is for my phase shift. All right, so pi minus pi, that's 0. 3 pi over 2 minus 2 pi over 2, that's just going to give me pi over 2. 2 pi minus 1 pi, that's going to give me pi. 5 pi over 2 minus pi, or minus 2 pi over 2, that's going to give me 3 pi over 2. And then 3 pi minus 1 pi is going to give me 2 pi. And there's my column I was looking for. These are numbers I recognize from the unit circle, and I do know the cosine of them. The cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine at 3 pi over 2 is 0. And the cosine at 2 pi is 1. In the next column, we want to multiply everything here by 2. 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. 2 times 0 is 0. And 2 times 1 is 2. And then finally the vertical shift. So we're going to take this column and we're going to add 3. 2 plus 3 is 5. 0 plus 3 is 3. -2 plus 3 is 1. 0 plus 3 is 3. And 2 plus 3 is 5. So the points I'm going to graph, pi over 3 and positive 5. Pi over 2, positive 3. 2 pi over 3 and positive 1. 5 pi over 6, positive 3, and pi, positive 5. All right, let's go over to the graph paper. So we'll put pi over 3 right here. And then we'll have pi over 2 right here. And then two pi over 3 right here. And 5 pi over 6 right here. And then we'll put pi right here. Now this time we're going to have to let one box stand for one unit. So we got 1 here, 2 here, 3 here, 4 here, 5 here, and then we'll have a -1 down in here, even though we don't need it. Alright, let's look at our points. We're graphing pi over 3 and positive 5. That's going to be right here. We want to graph pi over 2 and positive 3. That's going to be right here. We want to graph 2 pi over 3 and positive 1. It's going to be right here. Alright, we got 5 pi over 6 and positive 3. It's going to be back up here. And finally, we want to graph pi and positive 5, which is going to be right up here. Okay. And then we just sketch our graph in. And it's going to look kind of like this right here. And then the regular cosine curve. Let's see. At 0, we know the cosine would be 1. At pi over 2, we know the cosine would be 0. And at pi, we know the cosine would be down here at -1. And so if we wanted to see the regular cosine curve, it would be doing something like this. So it hasn't even headed back up to get to its next maximum point. We have a max, we have a min. This is just half of a period for the regular cosine curve, but this is the one that's been shifted up, and it's been shifted to the right pi over 3 times, and the period has changed to 2 pi over 3. Example 5. Given y is equal to -2 times the sine of the quantity, negative pi over 6 times x minus pi over 2 plus 1. Part A, identify the amplitude, period, phase shift, and vertical shift. And then part B, graph the function and identify the key points on one full period. All right, let's start with the amplitude. The amplitude is going to be the absolute value of that -2 there. The absolute value of -2 is just +2. The period is going to be 2 pi, that's the usual period for sine, divided by the absolute value of -pi over 6, because we do want the period to be positive. And when we do this division on the calculator, it turns out this is 12. The pi's are going to end up canceling each other out. The phase shift this is going to be pi over 2 divided by negative pi over 6. And that, again, when we do it on the calculator, is going to be negative 3. So the pi's are going to end up canceling out again. And then the vertical shift, that's just going to be 1. All right. We're going to come down here, and we are going to choose our angles. And then once I've got my angles, I'm going to multiply them by negative pi over 6. And then once I've done that, I'm going to subtract pi over 2. And then once I've done that, I'm going to take the sign of that column. So sine of negative pi over 6x minus pi over 2. And then I'm going to multiply that times negative 2. So we're going to have a reflection over the x-axis, and we're going to have a stretch here. And finally, I'm going to add that 1 in. Oops. And I'm not going to have enough room here to put my last column in. So I can write them on the next page, I guess. Well, maybe I can fit them in. So I can put them in there. Okay. So choosing my angles, remember I'm going to start at the phase shift, which is negative 3. And then I'm going to go out one full period. Well, a period was 12. So negative 3 plus 12 is 9. And I know these angles look funny because they don't have the pi's on there, but remember they are in radians. And the question usually comes up, can we graph these in degrees instead of graphing in radians? The answer is yes, but I grew up learning how to do this in radians instead of degrees, and so that's just normally what I default to. Okay, exactly halfway in between positive 9 and negative 3. We're going to add negative 3 plus 9, and then we're going to divide that by 2. So negative 3 plus 9 is 6. 6 divided by 2 is 3. So our halfway point is going to be 3. Halfway in between negative 3 and positive 3, that's going to be 0. Hopefully you can eyeball that one. Halfway in between positive 3 and positive 9, let's see, we're going to have 3 plus 9 divided by 2. That's 12 divided by 2, which is going to give you 6. All right, and here are the angles we're going to be choosing. In this column, we're going to take everything over here in our first column and multiply by negative pi over 6. So negative 3 times negative pi over 6, that's going to give me positive 3 pi over 6, which is just pi over 2. 0 times negative pi over 6, that's just going to give me 0. 3 times negative pi over 6, that's going to give me negative 3 pi over 6, but that's just negative pi over 2. 6 times negative pi over 6 is going to give me negative 6 pi over 6, but that's just negative pi. And then 9 times negative pi over 6 is going to give me negative 9 pi over 6, but that's just negative 3 pi over 2. Okay, next column. Now we're going to subtract pi over 2. Pi over 2 minus pi over 2, that's going to be 0. 0 minus pi over 2, that's going to be negative pi over 2. Negative pi over 2 minus pi over 2, that's negative 2 pi over 2, which is just negative pi. Negative pi minus pi over 2, that's going to give me negative 3 pi over 2. And then negative 3 pi over 2 minus pi over 2 is going to give me negative 4 pi over 2, which is just negative 2 pi. All right, so now we're going to use our unit circle, but this time we're going in the clockwise direction. So instead of doing pi over 2, we're going to do negative pi over 2, which is the same thing as 3 pi over 2. All right, with the sign of 0, that doesn't change. That's still going to be 0. Negative pi over 2, when we rotate down, that's going to be 3 pi over 2. So the sign of 3 pi over 2 is negative 1. Negative pi, that's the same as positive pi, where the sign is 0. Negative 3 pi over 2, that's going to take us all the way up to positive pi over 2, and the sign there is positive 1. And then negative 2 pi, that's just a full trip around the circle. That's the same thing as positive 2 pi, where the sign is equal to 0. In the next column, we're going to multiply everything in this column by negative 2. Negative 2 times 0 is 0. Negative 2 times negative 1 is positive 2. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. And negative 2 times 0 is 0. And on the last column over here, our vertical shift, we're going to add 1 to everything. 0 plus 1 is 1. 2 plus 1 is 3. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And then 0 plus 1 is 1. The points I'm going to graph, negative 3, positive 1. 0, positive 3. Positive 3, positive 1. Positive 6, negative 1. And positive 9, positive 1. All right, let's go to the graph paper. Okay, so let's see. Negative 3 is going to be right here. This is 0. Positive 3. Positive 6. Positive 9. And we're going to have to go with each box stands for 1 unit. Oops, skip 4. Okay. All right, so our points. Negative 3 and positive 1. That's going to be right here. Next point, 0 and positive 3. That's up here. Next point, positive 3 and positive 1. That's right here. Next point, positive 6 and negative 1. That's going to be right here. And then our last one, positive 9 and positive 1, going to be right here. All right, and all that's left is to just sketch this graph in. So we're going to go up, grab our max, come back through here, do our min, and come back up to the midline there. And there's our graph. Example 6 has to do with sinusoidal behavior and something called harmonic motion, and we'll be going over that a little bit more detailed in chapter 6. And so I'm going to skip over example 6 for this particular section, and we'll come back and do that when we get to section 6.4.